Yeah, I think we can start now. So last time I explained the idea of using masks. Okay, I told you if you have an IP address, you can use the mask to extract the network address or the sub-network address. Okay, that's what I explained last time, and I told you we can express this mask in two different ways. One way, it can be something like that. I can give you a number like this one, 255, 255, 255.0. This can be a mask. And in order to extract the sub-network address, you have to do logic AND, bit by bit logic AND, as I explained last time. Okay. Also, I told you last time, this mask, we can express this mask using slash. Yeah, so yeah, that's what I explained last time. You can use a slash. For example, if you have a mask, something like that here, as you see here, this one here. Okay. So here, this mask, you have one here, so you can say it's slash, and then you put how many ones you have. Okay. So this is what I explained last time. Okay. One of the things I said last time, and I think we're going to have example today. If I receive an IP and I want to know if this computer in the same subnetwork with me or not, very simple way, you can calculate the subnetwork of this IP and you can compare it with your subnetwork. If it is the same, that means this computer is in your network, okay? So also last time I started to explain the idea, how can you use masks here in the routing tables? So in the routing tables, I'm not gonna list every IP, okay? But in the routing tables, I'm gonna put the network addresses, or I'm gonna forward based on the sub-network addresses, okay? Not individual IPs. And I told you last time, this is a very smart idea, very good idea for scalability, because we have too many computers. Also, last time I give you an example like this one. I give you this router. So here we have router R1. It's connected to three networks. This network is here. This is our subnetwork, whatever you want to call it. So this subnetwork address is here. Okay, this is a subnetwork address for this network. This is a subnetwork address for this network, subnetwork address for this one, subnetwork address for this one. Okay, so all what you have to do here in the routing table after I receive the IP, all what I have to do, very simple. I'm going to extract the subnetwork of the IP. If it is here, so I'm gonna forward it through ME0. Okay, ME0. If it is not, so I'm gonna try to see if it is here, if this is the subnetwork of this one. So here, if yes, I'm gonna forward it through M1. If not, I'm gonna try this one. If it is here, I'm gonna forward it through M3, okay? If it is here, so I'm gonna forward it through M2. If it is none, if it's not any one of these, okay? I'm gonna also forward here through M2, but it has to go to the router so that the router can take care of it. You got what I'm saying? How I'm gonna do it? So this is very important example. I'm gonna give you another example. You have a question like this one in the assignment, and I think in the final exam, maybe this one of the attractive things for me to ask. I can give you something like that, and then I'm gonna ask you what is the routing table. Okay, so I think I can go through this example quickly. You have another example as I said. So let's start explaining this one. For example, let's start one by one. For example, ME0. In order to forward the packet through ME0, okay. So here it has to be this should be the subnetwork address. So all what I'm gonna do, as you see here, this is ME0 as you see here, okay. So I'm gonna see here, I'm gonna apply this mask /25. Okay, this is the mask here, /25. Is if I apply this mask and then I find so when I receive an IP, let me tell you how it works. Okay, before I tell you how we're gonna create this routing table, assume you already have the routing table. When I receive IP, all what I have to do, number one, I'm gonna go through this routing table this way. Okay, every time you receive an IP, I'm gonna go through this one. I'm gonna apply this mask. okay, to the in order to extract the subnetwork or network address. If I find the network address is equal to this one, I'm going to forward it through M2. If not, I'm going to go to next one. I'm going to check this one to extract the subnet, the network address. If it is equal to this one, I'm going to forward it through M0. Okay, and there is no, you can see here this column here. There is no next hub because it's you are going to deliver directly. There is no another hub. Okay, the only way you can have a hub here is here. When it is not here, it's not here, it's not here, it's not here, and I have to send it to the router. So the router is going to be one hub. Okay, so if not, I'm going to try next one. If not, I'm going to try next one. If it's not any one of these, so I'm going to send it to the router. Okay, this is how routing happens. So now I'm gonna explain how can you create this table, because again you have this question in the assignment. In the final, maybe I can give you this one of the things attractive to me. I can give you a question like this one. I'm going to give you two examples. This one example I explained last time. I'm going to go through it again quickly now. It's very easy. I'm going to give you another example. So let's explain one by one. Okay. So first of all, you have M0 here. M0 is connected to one network here, as you see. Okay. So in order to forward the packet to here, when I apply this mask, I should get this address. Very simple, right? So this is exactly what I did here. So for M0, as you see here, when you apply this mask, you should get this address. If this happens, so you have to send it through M0. Okay. Same thing. Let's talk about M1. Same thing for M1. M1 here, it's connected to only one network here. Okay. So if I apply this mask here, okay, so I'm gonna send it through M1, as you see here. Okay. Same thing here for M3, for example. It's connected to one network here. So through M3, it's the same thing. I'm going to apply this mask to the IP if the address is equal to this one. So I'm going to send it through M3, as you see here. Okay. M2 is going to be listed twice. M2. Why? Because there are two cases for M2. One case is the computer or the station is here in this network. So in this case, I'm going to deliver it directly. This one case. The second case, because the router here is connected, this router is going to connect me to the rest of the network or the internet. Okay. So the second possibility, I don't find the computer in these four networks, and in this case, I have to send it to the router. So that's why I'm going to list it twice, and that's what I did. As you see here, I'm going to list M2 twice. One time is going to be direct delivery. Another time, no, I'm going to send it. I'm going to send it to the router. This is the address of the router, as you see here. This is the address of the router here. This router. Okay. So I'm going to send it to the router. So, and if it is in this network, if the IP here in this network, if I apply this mask, I should get this address, and that's exactly what I did here. Okay. Any questions? Is that easy? If I bring something like that in the exam, you already have in the assignment something like that. Okay. I'm gonna give you another example. So as you see here, every network has only one record, except if you have router here. If you have another router here, you are gonna have two, because the computer can be here, or if it is in any one of these. So in this case, I'm gonna send to the router to send it outside the internet to another net. Let's see another example here. Okay. So as you see here, I want to calculate the routing table for R1 here. Okay. R1 is actually connected, as you see here. R1 actually is connected to this network. Okay. To this network. Also, R1 is connected to this router. This is the router to send it to the rest of the internet. Okay. R1 also is connected to router R3, and R3 is gonna be one hub for this network and this network. So how many networks you have here? I have this network, but I am not directly connected to this network. Okay, it has to be through R3. So there should be one hub here. Okay. Also, this is a second network. So you have one network here. You have a second network here. You have a third network here. Is that okay? This one directly delivered. I can deliver it directly. And number 4, if it's not any one of these, so I have gonna send it to this router to transmit. Is that okay? So let's see how we can do it. So let's start, for example, here. So M0 here has to be listed twice. One time, if the computer here in this network, I'm gonna deliver it directly. The other time is if it's not any one of these, so I have gonna send it to the router to send it to the rest of the network. So let's start with this one here. So here I don't give you the mask here, but you can know the mask. Why? Because I told you if I go back here and this is something you need to memorize. It's not difficult, but you need to memorize. I'm not going to give it to you in exams or something like that. Last, I also explained before the idea of classes, having different classes. Okay, so for every class, this is a mask for every class. You need to know these masks. Is that okay? So as I told you last time, or as I told you before, yeah, let me go back to here. Okay, if it is, how can you notice class A? There should be 0 here, as I explained. Also, the mask here is going to be only 1 byte, so it's going to be 255.000. Okay, here 255.000. Here 3 anyway. So you need to know these masks. This is in case of network address. If it is sub network, I have to give it to you. Okay. So let's come to here again. So for example, let's start with M0. I told you M0, there are 2 cases for M0. The first case, I'm going to deliver it directly to this one. Okay, and this is the case here. So as you see here in this case, I'm going to say this is the network address is here. Okay, and this is the mask. The mask here is for class B. Okay, class B. Again, I didn't give you the class here because this is for network, and for network, you can know the classes. But for the sub network, you need the mask. You need the mask. Okay. So here, this is the mask. So if I apply this mask and I find this is the network address for the IP. So it's gonna be when you see slash here, that means it's direct delivery. There is no next hop. Okay, and it has to go through M0. Okay, so one thing, the other thing is also through M0, as I told you before, through M0, I can send it directly to the router, as you see here. So that means if anything else, and any here can be accepted like 000, and I'm gonna get 000. So if you apply, this means any, right? So because if you apply 000 and then you do end, logic end, for sure for any IP you will get 000. That's why it's any. So anything else, because this one it will be always true. If you apply 000, you will get 00 because you do logic end. Anyway, so if this is the case, because you are gonna search this table in order. In order. So I'm not gonna start from here. I will create this one first. I'm gonna create this one, create this one. If all of the fails, that means the ID is not in this network. So I have to say this one will work. All the time this one will work. Okay. But I'm gonna search the other ones before I come to this one. Okay. So here, so if this is the case, so here it has to go to R2. That means it has to go through M0. Also the address here, there is a next hop. So this is the next hop is here. Okay. Let's look at these ones here. It's exactly the same thing. Number one, it has to go through M1. So that's why M1 has to be listed twice. M1 has to be listed twice. One time for this network and one time for this network. Okay. Number two, here also we have a next hub because it's not directly delivered. So it has to go through this address, and that's exactly what I did here. Let me, okay. So what I did here, M1 is listed twice, as you see here. One here, this is the mask, and this is the address for this network. This is the address for the second network here. And in both cases, I have to send it to this router. So that's why we have a next hub. Any questions? فين انهي خطوه؟ This one? I think it's some kind of it's not a network. It's not a network. It's some kind, yeah, like a bus or connection, something like that. You get what I'm saying? But it's not a network. Okay. This is a network here. When I give you this address, this is a network. You have 3 networks. This one. Okay. Any questions? Yeah. One of the very interesting things here and very important for scalability, something we call it address aggregation. You can aggregate addresses in order to make the routing table shorter. Okay. Again, the main problem here is the scalability of the network. We have too many computers. So the idea of using hierarchy and also the idea of using masks and using aggregation is going to help me to make the routing table shorter. You'll understand exactly what I want to say here. Okay. So here we assume we have two routers, as you see here. We have here router, I'm going to call it router R2. We have router here R1. R1 is connected to actually these networks. This network can be an organization, as I told you before. This is another organization. This is another organization. This is another organization. And as I told you before, and also as I'm going to give you examples today, this is actually is not only one address. Okay, as I'm gonna elaborate today. This is a block of addresses. Because, for example, if you have Qatar University, I'm not going to give only one IP to Qatar University, right? Because we have too many computers connected to the Qatar University campus. You understand what I'm saying? So this organization has too many computers. So I have actually what happens, I'm going to give like a block of several addresses to the company or to the organization. And then the organization can use these addresses to connect to computers. So this actually, you understand it better today. So when you ask for, actually it's very obvious here. So I can go back here if I go here. Yeah. For example, here, if I give you a class A, so here it has, this is a network ID, and then this is the host. So you can, so if I give you, for example, here I put in the network ID any number like 223, for example, and then dot, then here you can change the host. You can change the host addresses. So now you can have up to 2 to the power of 24 computers. You understand what I'm saying? So if I give you a network ID, so actually I'm not giving you one IP. I'm going to give you a bunch of IPs to use them. Okay. In this case, it's going to be 2 to the power 24. If I give you one here with less speed, it's going to be 2 to the power 16. If I give you, your network address is in class C, it's going to be 2 to the power 8. How many computers you can access? What you should understand. Anyway, I'm going to give you examples today to understand it better. Yeah, but let's come to the idea of aggregation here. Okay, so if I want to make the routing table for R1. Okay, so as I have just explained right now, what I'm going to do for R1 here, you have M0, you have M1, M2, M3. For each one of them, I'm going to list the mask, and then I'm going to list, as you see here. So look here. Here I'm going to list the mask and the address for each one of these. For sure, at the very end here, I'm going to say we need one record here, or if it is something else. But anyway, this is not the main idea here. The main idea or the idea of address aggregation is, look here. For R2 here, I don't need to list. So this is the routing table. This is the routing table for R1. Okay. For R2, I don't need to list all these networks. That's why I'm gonna do aggregation now. Instead of having 1, 2, 3, 4, instead of having four records here or four rows here, I'm gonna express it only in one row. That's why we have aggregation. So the idea of aggregation is that here at R1 here, instead of listing all of this here, no, I'm not gonna do that. All what I'm gonna do, I'm gonna go one level, so one level less. So here it is 26. So I'm gonna say here, if when I receive any IP and the IP has this common part, you can see here, there is one common part between all of them. Okay, this part is common between all of them here. Okay. So I can aggregate these addresses together, and I'm going to say only here, once you find this common part, just send it through M0 here. You understand what I'm saying? So I don't need to list everyone individually. I'm gonna see what is the common part in all of them. So any IP I receive with this common part, I'm gonna forward into M0 instead of list again 4 times. Is that okay? Just to make the routers shorter. Here I can do this one here. I can't for sure. Because when I receive a packet, I have I have to send it this way or that way or this way or this way. But, and this is related to what I told you before, somehow related to what I told you before. If you have, for example, an organization like, for example, Qatar University or campus or a company or anything else, okay, everyone else will see you. Everyone else will see you as only one network. You'll see, like, we're using only one address. So the outside world will deal with you, okay, using only the network address. Okay, so any packet coming to Qatar University campus should have only one common part. So this is what the world will see you only using this part. Okay, so it's also a kind of aggregation, because I have too many addresses here inside Qatar University. I have too many addresses. All these addresses, I can aggregate them using only the network address. Okay, now I'm going to give you more examples on again, what I want you to understand. I'm going to give you several examples, but the conclusion is when an organization asks for a bunch of IPs, they are going to give you a network address. Okay, and as I told you last time, if you have here, if I give you several IPs, everybody else will see using the network address. But internally, inside the organization, internally, you have the freedom to design your own network as you want. What do you mean? I mean, once you have the outside world will see you using the network address. Okay, but internally, you can have sub-networks. Okay, for example, here in Qatar University campus, this building can be one subnetwork, another building can be subnetwork, and then I'm gonna connect these networks together. This is how you did it. Outside the network, I don't care, I don't know. That is why, as you will see, the subnetwork addresses are gonna be used here internally, but outside we are gonna only use the network addresses. Okay, I'm gonna give you example right now, and I think this is also a very important thing. You have one question in the assignment. In the final exam, I'm gonna give you, maybe I'm gonna give you something also like this one. You will see right now, I'm gonna give you network address, and then I'm gonna ask you, I wanna create an organization. In this organization, I wanna have 4 subnetwork or 5 subnetwork. Tell me what are the addresses. So you will see right now how we will do it. Okay, but what I want you to learn is everybody outside the organization will see using the network address. How you created your network, how many subnetwork you have, what are subnetwork addresses. This is internal matter. Only the university or this network can know it, right? I don't need to tell the outside world about it. Okay? Very interesting, very important, because for several reasons. Number one, it can give every organization some freedom to design the network as they want. Also, for routing, I don't need to know the details. What do you do here inside? But anyway, let's go through these examples here. Okay, so here, this is one of the things. Give me this address. This is an address, and I give you the network address. We call it the default mask address or the network address. By the way, as I told you in exams, I may not give you the network address, because you can know the network address from the class of the IP. Anyway, so I give you here the IP address, and very easy question. I'm asking you about what is the network address. Okay, here. So you know this is class P. Okay, because it is class P here, the mask here. So the network address is going to be this. You are going to do AND, as I explained to you before. You can take this one and this one, as you see here. Okay, after you do AND, and then 0, 0. So give this is IP. This is the network address of this IP. So this IP belongs to this network address. Okay, I'm not talking about subnetwork now. Subnetwork is coming. Let's see another example here. Also, if I give you this one, and this one is actually class A, and in class A, this is the mask for class A, 255.0.0.0. So if you wanna calculate the network address from this one, so I have to keep this one. I have to put 0, 0 everywhere, because this is 255 when you do AND, as I explained last time. So it's going to be this is the network address. Okay, so again, if I give you an IP, it should be easy for you to number one. This is maybe a question in exams. I give you IP. I tell you what is the class. Please calculate the network address of this one. Okay. Any questions? Okay. Here I'm asking you a host. This is the host IP. So you should be familiar with some terms like host IP. This is IP for a computer. Network address. Also, you have sub-network address. Okay. So this is here again. Given the IP, you can calculate the network address. It's very easy, right? Once you know the class, you know the mask, you can calculate the network address. But you can't calculate the sub-network address. Because the sub-network address is something you can design as you want. That's why it's going to be given to you. So if I'm going to give you the sub-network mask to calculate the sub-network address. Okay. So maybe in exams or something like that, I'm going to give you only IP. That's this one alone. And then I tell you what is the network address. Is that okay? This should be enough. But for sub-network, it's not enough because you can design the sub-network in different ways. Okay. For example, in what I give you all these addresses, you can decide. For example, I'm going to use all addresses for only one subnet. Okay, that's your decision. Or I'm going to divide into two. Okay, this is something I can't guess, or I don't know. So that's why you need to give me the subnetwork mask. So here I give you the subnetwork mask, and then I'm asking you to calculate the subnetwork address. Again, all what you have to do here, you have to apply the subnetwork mask to using AND operation, because this one is 255 to calculate. So given the IP and given the subnetwork mask, you need to apply the mask using logic AND to get the subnetwork address. So this is 255. So it's going to be 140, 141, then 14, 0, 0. So this is the subnetwork address. And I told you, and also this may be a question in exams as well. Okay, very, very easy, but you need to know it. If for sure, as a host, as a computer, I know my subnetwork address. Is that okay? I know my subnetwork address. If I receive an IP, and I want to know if this host is my neighbor in the same network or not. Okay. All what I have to do is that I have to calculate the subnetwork of this IP. If it is equal to my subnetwork, so yes, it is my neighbor. Otherwise, no. Right? So, for example, I think I have here. Yeah, I think if the host wants to send a datagram to this IP, you have to check if this destination is the same subnetwork like me or not. That's what I told you, right? So here, I want to send I want to send a message to this guy or to this address. So I need to know if this address in my computer or not. So all what you have to do, you have to apply all what I'm going to do here. I'm going to apply this mask, okay, because this is my subnetwork mask. My subnetwork mask, sorry, this is my subnetwork mask here. This is my subnetwork mask. If I apply this mask to any IP and I get this subnetwork address, so the answer is yes, you are with me in the same subnetwork. You get what I'm saying? So that's exactly what I want to do here. So maybe in exam, I'm going to tell you I am a host. So this is my IP and this is my mask. Then I'm going to ask you to calculate the subnetwork address. And then I'm going to ask you, I want to send the data to another host. This is the address of the host. So this host is this host in the same subnetwork like me, so that I can get it delivered directly, or it is not. So I have to send it to the router. How can you know? Very simple. All what I'm going to know, I'm going to apply this mask because my subnetwork has this mask. This mask here. This is a submask. This is the mask for my subnetwork. Okay. If I apply this mask to any IP and I find this subnetwork address, that means we are in the same computer. Otherwise, it's no. So that's what I'm going to do right now. So as you see here, for this address here, I'm going to apply this mask, and this is the result. Okay. This result does not equal my subnetwork address. So this computer is not in the same network like me. Any questions? Okay. Another example here, a router inside an organization receives a packet with this destination. Show how it finds the subnetwork address to route the packet. Okay, so again, so here when you have a /19, this is the mask. This one should be equivalent to this one because /19 means you have 19 ones. You have 1, 1, 1, 1, 1, 1. How many ones? 19 ones. Okay, total you have 32 bits. 19 ones, and then the remaining number, which is I think 13 is going to be zeros. Okay, so this is exactly equivalent to this one. Yeah, equivalent to this one. Okay, so this is the submask. So just from this one here, I can get the mask. This is the mask we have, and then I can apply this mask to this address here. Apply the mask to the address here, to this address, and then after that you can get the subnetwork address. Any questions? So again, if you have an IP and you apply the mask of the network, you get the network address. If you apply the mask of the subnetwork, you are going to get the subnetwork address. For the network, you need to know the masks because it's only we have 3 places. For every place, you need to know what is the mask. Very simple. For the first place, only 1 byte. Yeah, it's the second place is 2 bytes. Third one, 3 bytes. For the subnetwork, this is not something you can guess. This is something you can design. As I'm going to explain the next example. So for subnetwork mask, it's going to be given to you. It's not something you can guess. Yes.
Then doesn't فيها فوج.
ايوه عشان it's not in the same network with me. Yeah, because this is when I apply, this is okay. This is my IP. This is another IP for another host. I want to know if this host is it's the same subnetwork with me or not. How can you do that? Very simple. Apply the mask. After you apply the mask, okay, if you are gonna get this subnetwork address, so the answer is yes. Otherwise, no, it's no. You got what I'm saying? So what I did after I applied the mask here, I got this address. Okay, so subnetwork it doesn't equal my subnetwork address. So this computer it's not with the subnetwork with me. It's in another network. Oh, okay. Maybe something is wrong here. Oh, yeah. I think you are right. I'm sorry. I think something is wrong here. So if you apply this mask, here, as I said, so I'm gonna get this one. I'm gonna get this one, and then I'm gonna get 0 here. Okay, 0, 0. So it has to be yes. It has to be this one. So the answer is yeah. This is a typo. Okay, so if it is 0, 0, that means because it is equal, so it has to be in the same network like me. Okay. Again, what I explained is correct, but there is a typo here. All what you have to do is that you have. I know the mask of my subnetwork. I know my subnetwork address. I'm going to apply the mask, and then I'm going to compare the subnetwork address to my subnetwork address. Okay? Yeah, the second example here is very important. You have one question here in the assignment. I think in the final exam, I may bring something like this one. So here in this one, as I told you here, there is a company or organization or a Qatar University campus, whatever it is. So here I'm gonna give to this company a class C. Okay, so it has this address, which this one is class C. Okay, and then I'm telling you. So again, when I say, let me go back just to when I tell you this one class C here. Again, this is not one address. This is a network address. This network address can have many host addresses. Okay, so if I go back here to class C, yeah, this is class C. So in case of class C, so actually the network address here, the network ID is 24. So all what you have here only 8 bits. Okay, so I have 8 bits here. So total I have 2 to the power 8 computers. So if I give you a class C, okay, network address, that means you have 2 to the power 8. You can only connect to your organization using this network address. 2 to the power 8, 256 computers. Is that okay? So this is that's what I want to tell you. That's what you should understand. This example, you have a similar same example or in the assignment. Okay. So now I have here, you give me, once I tell you, I give you a class C network address. So actually, I'm telling you, I'm going to give you 2 to the power 8 IPs. So you can connect up to 2 to the power 8 computers, IPs. Is that okay? So that's what you have. Now, it's up to you. Do you want these 2 to the power 8 IPs? Because you can change this part here. You can change this part, okay? Starting from 8 zeros until 8 ones. You understand what I'm saying? So this part is common, but you can change this part from 8 zeros to 8 ones. Okay. So now it's up to you. You can create only one subnetwork that has 2 to the power 8 computers. I can make 2 networks. I can cut it in half. I can make it 3 subnetwork, 4 subnetwork. It's up to you. Okay. Whatever you want to. So here, I'm going to tell you the question. I'm going to tell you the company want to make, for example, 2 subnetwork or 3 subnetwork. Give me the addresses. So you need to calculate the addresses. Is that okay? How can you do that? That's what I'm going to explain now. But this is important example. What's that? They have to be the same size. You will understand now why. Okay. So you can see here. So this is the network. This is the network address. That means any inside my network, this is the common part. The common part is this one common part for all of them. But here inside here, I'm gonna make sub networks. Okay. Every sub network it has a sub network address. Okay, and also it has host addresses. You will understand. After explaining this one, you'll answer this question by yourself. Okay, so let's complete here. So here I'm asking you, so again, very simple, because this is class C. So now I have 32 bits. Any address is 32 bits, but the network ID is actually 24 bits here or 3 bytes. So all what you can control or all what you can change is only this byte. So you have only 1 byte here in this case, okay, to change. Okay, so the outside world is gonna, when I forward any packets to you, I'm gonna only look at this part. Okay, and then this is something internally. So now I have 2 to the power of 8 bits. So now I'm asking you, I want to make 6 subnetwork. Okay, so what I'm gonna do. So here, out of the 8, I'm gonna take here, as you see. So this is the network ID. So I can't change this one, network ID. This is the byte I have. Okay. Now, because I'm gonna take 3 bits. I'm gonna take 3 bits here for the sub network. And this one's here for the host ID inside the subnetwork, host ID. So now we have 3 things here. This is the network ID. I can do it now. So all what I have 8 bits. Okay. And because here he told you I need 6, I can't make 6. Why? Because it has to be 2 to the power of something. So here that's why I'm going to take 3 bits. So it's going to be 2 to the power 3, which is equal to 8. So either 2, 4, 8, 16, it has to be 2 to the power of something. So if I ask you, we need to make 6 subnetwork, you have to look for the nearest 2 to the power of something. That's why I'm going to make it 3 bits. So this 3 bits is going to tell me which subnetwork. So these 3 bits actually are going to be from 0, 0, 0 all the way until 1, 1, 1. So, but by this way, so this is the subnetwork ID. You understand what I'm saying? So now I have 3 bits. I'm going to decide here 3 bits here for the subnetwork ID. And for each subnetwork, I have here 5 bits to have 2 to the power 5 computers. You understand what I'm saying? So now I'm asking you, number 1, give me the subnetwork mask. So the subnetwork mask, I'm going to put here the network ID. And then I'm going to put here, this is a mask. So here, because it's only 3, it's going to be 111. So it's going to be /27. Originally, it was for the network here. For the network mask, it was /24. because this part is the network mask. Okay, but for the sub network is going to be /27. Okay, so this is the mask for the sub network. That okay? So let me elaborate here to understand exactly what I want to say. So it's very simple. All what I want to say here is that we have here, I'm going to change. This part is fixed. I'm not going to, this part here, this part here, this byte, this is fixed for all the computers. I'm not going to change it. Okay. So so I have here 2017064. This is fixed. I'm not going to change it. Okay. Now all what I'm going to change only this byte. So what I'm going to do here in this byte is I have a byte here. I have here 3 bits for subnetwork. And then I have 5 bits for the host. 5 bits for the host. So here I can have here 000, right? For subnetwork number 0. Subnetwork number 0. So here put 0, this is subnetwork number 0. And then for the host addresses here, they can go from 5 zeros all the way until 5 ones. So this is going to be one subnetwork. One subnetwork. Second subnetwork, this would be 1. And then here, it's the same thing, 0, 0, 0 until 1, 1, 1. Next subnetwork, this is 2, number 2. And then also the same thing here. Okay. So just I'm going to take some bits for the subnetworks. I'm going to change it from 0 until 8, until 7. Total, they are 8. Okay. And then for each subnetwork, I have 5 bits for the computer. That's why this can answer your question now. So number of computers in each subnetwork should be the same if you do this way. Okay? But anyway, so now the question is that, and I can ask you this question. Please give me. So now we should be able to calculate the subnetwork mask this way, as I told you. Okay. Also, you should be able to get. You should be able to calculate the subnetwork address for every subnetwork. Okay, the subnetwork address for every subnetwork. You should be able to calculate all range of addresses in every subnetwork. Okay, so as you see here, for example, in the first subnetwork, again, we agree the first part here, I'm not going to change the first 4 bytes because this is the network ID. All I'm going to change only this byte. Okay? So all what I did here, as you see, this is the first network here. I only change this one here as I told you. This one has 0, 0, 0. Okay. And then here, this is a part, this 0, 0, 0 is common for all of them. It's common for all of them, all the computers here. And then this ones, I'm going to change it from 8 zeros until 8 ones. This is going to leave you with, this is the beginning address, the first address in this subnetwork, right? From 0, 0, 0, 0, 0. If you put 0, 0, 0, and then you put 1, 1, because this part, this is the subnetwork ID. So this part is common for all computers here in this subnetwork. Okay. So that's why you have addresses from 0 until 31. 31 actually is 0, 0, 0 for the subnetwork, and then 5 ones. You got it? Let's see the second subnetwork. It's exactly, I'm going to repeat everything. All what you have to do here, I just change this one to 1. That's it. Okay. Because of that, this one is going to be 32. Okay. Because this one is going to be actually 0, 0, 1. And then I'm going to start from 5 zeros. Okay. All the way until 5 ones. So you can get this one and you can get this one. You can get this one and so on until the last one. In the last one here, because you have 8, we have 8 of them. In the last one here, this one, you actually in the subnetwork here, we are gonna have 1, 1, 1 in the subnetwork. Okay, but in the host, you are gonna start from 5 zeros until 5 ones. Is that okay? So again, in this question, I'm gonna give you like something like that, class A or B or C. That's number 1. Number 2, I'm gonna tell you how many subnetwork I need. Number 3, I'm gonna ask you to give me number 1. So subnetwork mask for this case, in this case, this number 1. Number 2, I'm going to ask you to give me for every subnetworks, what is the range of addresses I have? So this is the beginning, this is the end. This is the beginning, this is the end. This is the beginning and the end. Number 3, I'm going to ask you to give me the subnetwork address. By the way, can anybody tell me what is the subnetwork address here? Just for each one has a sub-network address. (201.70). No, this part is the network ID. Okay. Okay. So here is actually it's always the first address here. The first address. I'm going to tell you why. Simply because here, this part we're not going to talk about this part. The first three numbers. This is for the network. Okay. Let's talk about this one. So here we have a byte. Okay. So here we have 3 bits for the subnetwork. So for example, here in this case, it is 0, 0. This is a part that's common for all of them. Okay. For the second one, this part is number 1, number 2, number 3, and so on. Okay. That's why if I apply this mask, here, if I apply this mask, I'm gonna get this spike, I'm gonna get this spike, I'm gonna get these 3 bits. You know what I'm saying? So, and this is actually the first address here. Okay. Because you know, as I said before, if you want to calculate the network address, you have to put 0 in the sub-network address ID, and also the host ID. You have to put 0 everywhere. Okay, this gives you the network address. For the sub-network address, you have to keep the network ID. You have to keep the sub-network ID, and then you have to put 0 in the host ID. Okay. So that's why this part. So that means, let me say it again. If you apply this mask, to any address here, you will get the first one. Why? Because you are gonna keep. I'm gonna only take these 3 bits, and these 3 bits are common here. Is that okay? Same thing here. If I apply this mask to all of them, I'm gonna get this one for all of them. Okay. Because I'm going to keep these 3 bits. I'm going to cancel the host number ID. Any questions? So here, this is a very important thing, as I explained it before. This is like an organization. The outside world is going to see you using the network ID, but internally, I think. No, I think this is not related to this example, but anyway, yeah. So this is just, this is not related to this example, but that's what I told you before. If you have any organization, something like this one, okay. So this is something different. So here, what I'm telling you, if you have an organization like this one, this is a network ID. So the outside world is gonna see you using this network ID. So every time you receive a packet, and the network ID for this one is going to go to this place. Is that okay? Internally here, that means the outside world doesn't need to know how you divide it this way. Internally, okay, you are going to have sub networks here, and the sub network addresses are going to be used by your routers. Your routers are not going to be used by the outside world. So only the institution routers can know the subnetwork here. So subnetwork address are going to be used locally here. So what happens after R1 receives a packet, it has to calculate the subnetwork address, and then either it's sent to here or here or here or here. Is that okay? Any questions? Okay. I think this is enough. We need to take the attendance. So as I told you before, the quiz is going to be May 2nd.